Section 8-5, Classifying Polygons. Today we're going to learn to identify and name some polygons. We know that a polygon is a closed plane figure formed by three or more line segments. Each line segment forms a side of the polygon and meets but does not cross another line segment at a common point. This common point is called the vertex. So I have my common point. I'm going to draw a line segment, and a line segment. This polygon has three sides. It is closed, and none of the lines are intersecting over each other. And they meet at a common point, always known as our vertex. Of course, this polygon is known as a triangle. Polygons can have as many sides as you want, as long as there are three or more. So, we have a polygon here. We have identified its sides. Let me get rid of this guy in the way here. It has 6 sides, 1, 2, 3, 4, 5, 6. We would call that a hexagon. Now, it doesn't look like a regular hexagon, but it is a hexagon. We have sides and we have our vertex. Vertices is the plural for vertex. So if you have more than one vertex, then we call them vertices. So let's see if these figures are polygons or not. And if they aren't, we need to tell why. Let's look at figure A. Do you think that's a polygon? Remember our definition, 3 or more sides. It has to be closed, and nothing can overlap. Do we have a polygon? Let's see. It is a polygon. It is closed, and it has 4 line segments. Let's check out the next picture on B. We have to make sure it has 3 or more sides. We have to make sure it is closed and that nothing overlaps. Well, do you think it fits our definition? It is not a polygon. It is not a closed figure. Big old gap in there. Let's see if these are polygons or not. Now, we talked about sides, and we need to have at least 3 of them. But what do we need to make sure about those sides? They have to be line segments. Are these line segments? That's what you want to ask yourself. Of course, it has to be closed, and nothing can intersect. So, is this a polygon? No, it is not, because it is not formed by line segments. These are curved. They are not line segments. Let's look at D. Is that a polygon? Which of our 4 does it not follow? Is it 3 more sides? Are they line segments? Is it closed? Do they not intersect? What do you think? It is not a polygon because we are intersecting. These lines are crossing each other. It is not a polygon. Let's see if these are polygons. Let's pause, and then you write yes or no, and if it's no, you have to tell me why. Pause now. All right, we're back. Is a polygon? It is a polygon. It is closed. It has 5 line segments. What about B? Is that a polygon? Oh, it's not a polygon. It is not a closed figure. I can get inside of this shape. Let's see if these are polygons. Pause now and write yes or no, and if it's no, tell me why. welcome back. Let's look at C. I think that's a pretty easy one. I hope you said no, because those are not line segments. If they curve, they're not a line segment. What about D? Yes or no? D's a little tricky. What's going on there? It is not, because we do have them intersecting. It's going into the shape. Now, when we know we do have a polygon, we have to be able to give it a name. So we're going to name it by the number of sides and number of angles it has in it. So that one's pretty familiar. It is a triangle. 3 sides, 3 angles. Quadrilateral. Quad means 4, 4 sides, 4 angles. It's got 5 sides. What is that? A pentagon. 6 sides? I'll bet you know that's a hexagon. This is an unusual one. A heptagon has 7 sides. Those are hard to draw. Our good old 8-sided figure is our octagon. There's one. How many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9-sided is nonagon for 9 sides and 9 angles. And our good old 10-sided buddy is the decagon. Deca, like decade, 10 sides, 10 angles. So let's name some polygons. 1, 2, 3, 4, 5, 6, 7, 8. I bet you know that that is an octagon. Notice how I'm putting slashes so that I know where I started and stopped. 1, 2, 3, 4. 4-sided figures are quadrilaterals. Let's see if you can name these on your own. Pause and see if you can name these polygons. Alright, welcome back. A is a quadrilateral. It has 4 sides. B, of course, is a pentagon with 5 sides. A regular polygon is a polygon in which all sides and angles are congruent. And don't forget, congruent means exactly equal. So, tell us whether these are regular polygons. We know they're polygons, but let's see if they're regular. Remember, our slash marks indicate something about polygons. 1 line, 1 line, 1 line, 1 line means those are all equal. 2 slashes for my angle on every single one means they are equal. So this is a regular quadrilateral, and it is called, of course, a square. Now this figure, we have 2 slashes with 2 slashes, so they're congruent. We have 1 slash with 1 slash, so they're congruent, but they're not congruent all 4 sides. That's going to be a problem. So this is a quadrilateral. It is not regular because not all sides are congruent. Alright, your turn. Tell me if these are regular or not. Pause now. Alright, welcome back. I hope that you told us that this is not a regular polygon. This side did not have the same 2 slashes to indicate it was equal, so it is not regular. Let's try B. This is regular. Each side had 1 slash. Each angle had 2 slashes. Alright, let's see whether it is a polygon. Well, and then we're going to name it. So let's look at this very closely. Look at everything that's there. 1, 2, 3, 4, 5 sides, but look at those sides. What do you think? Yes, it is a pentagon. 5 sides. It's called a pentagon. Let's look at number 2. Is that a polygon? No, I can get into it, so it cannot be a polygon. Number 3. All of the sides are the same. And it looks like all of my angles are the same. Let's count our sides. 1, 2, 3, 4, 5, 6. There's one there. It's hard to see. 7, 8. So what do you think that is? Yes, it is an octagon. Alright, is this figure a polygon? Well, let's see. We've got sides here. We've got this dude going this way. What do you think? Polygon or not? No, we had that curved line. No curved lines in polygons. That was the end of 8-5, classifying polygons.